Welcome to again our series where we are learning and discussing about computer networks fundamentals. So this is just a recap on MAC addresses using question and answer technique. So I'm hoping that this short part will be super useful in recalling the different concepts we have learned about MAC addresses in computer network series. So let's go through these questions one by one. So the context here is this is a short recap on what we have covered so far in previous videos for MAC addressing. This will give you an opportunity to think about what we have learned so far using question and answer technique. And I'm just going through the question and answers we will be covering in this part for our computer network series. So let's start with first one. What does MAC stand for? So it's media access control. So though it is easy to remember, but logically, if we think about these keywords, so media access control means basically using the MAC address, we can get access to the network connectivity. So it's just to control the access for the media is what MAC does stand for. So what is a MAC address? So we have learned in previous videos in our computer network series that computer network is essentially a group of devices uh, connected in a given network. So now every device basically has an IP address, but at the same time, every device can have multiple MAC addresses. And specifically, in any device, there are some network interface cards. In short, we call them NIC. So basically, this MAC address is always associated with network interface card. And this address uniquely distinguishes network interface card in a device. So in a nutshell, what is a MAC address? So it's a unique hardware identifier permanently burned into network interface card by its manufacturer. The next one is how many bits is a MAC address? So we can just remember it, it's 48 bits. How many bytes is a MAC address? So previous to the bits, as it is 48 bits, so if we divide it by 8, so it is going to be 6 bytes. So overall MAC address is 6 bytes and 48 bits. How many unique MAC addresses are possible? So as we had seen previously, that in every bit, it can either be 0 or 1. So it means that every bit can contain maximum of 2 digits, 0 or 1. So based on that, if we have 48 bits, then it means we can have maximum 2 to the power 48 MAC addresses, which is approximately 281 trillion. What format is a MAC address written in? So it's basically the combination of, like, it's the hexadecimal format, to be in short, which is, hexadecimal numbers are like 0, 1, 2, 3 till 9, and after that A, B, C, D, E, F. Okay, so that's the hexadecimal characters we have in a number system. So in terms of MAC address formatting, so it's hexadecimal format where we have 6 pairs of characters, as we can see in this example. It's A4 colon C3 colon F0 colon 85 colon 72 colon 1B. So the separator for these six pairs can either be colon or hyphen, or depending on uh, the uh, the guidelines provided by the manufacturers of the network interface cards. So what are the two parts of a MAC address? Okay, so we had seen previously that every MAC address contains two parts to it. So first one is like which company or manufactured this network interface card for which this is the MAC address. So first 3 bytes uh, identifies the manufacturer, and then the last 3 bytes identifies the specific device or a specific network interface card. Okay, as we had seen earlier that the total size of a MAC address is 48 bits, which was 6 bytes. So out of 6 bytes, 3 bytes are first 3 bytes represent the manufacturer, and last 3 bytes represent the device itself. Okay, so we just maybe like sometimes if you're going through different tutorials, or you are reading something about computer networks and MAC addresses, then you might face this term OUI. So OUI is nothing but it stands for organizationally unique identifier. So it's the first 3 bytes which tells who the manufacturer is. So OUI stands for, in short, like who is the manufacturer. So organizationally unique identifier. Then who assigns these OUI blocks to manufacturers? So basically it's the institution IEEE, Institute of Electrical and Electronics Engineers, which is an institution, and this institution assigns the OUI blocks to the manufacturers. For example, like if you look at the previous example of our MAC address, so here first 3 bytes, right? So it can be a network interface card manufactured by Intel, or let's say some other company like Apple or Google. So basically, then every manufacturer like Apple, Google, or Intel, they need to have this manufacturer ID, right? So it's IEEE organization which assigns these unique identifiers to each manufacturer. And that is what OUI stands for, organizationally unique identifier. Then the next one is NIC. What is a NIC? So network interface card. So it's the hardware component inside a device that allows it to connect to the network. So basically, if we want to build up a network of computers or devices, then there has to be a network interface card so that it can communicate or it can connect to a network. The next one is, can a laptop have more than one MAC address? Yes. So one for each network interface card. So as we have just learned that uh, MAC address is associated with network interface card, and in our a laptop device, for example, so we have the Bluetooth connectivity, we have Wi-Fi connectivity, and we have Ethernet connectivity. So then it means that yes, laptop can have more than one MAC addresses, each one different for Wi-Fi, Ethernet, and Bluetooth. Is a MAC address permanent? Yes. At the hardware level, yes, it is burned into the chip, but it can be overridden at the software level, and that is called MAC spoofing. We have not yet gone through what MAC is spoofing in detail, but for now, you can learn that, or you can remember that at the hardware level, MAC address cannot be replaced. It's permanent, burned into the chip. But at the software level, it can be modified, or it can be overridden, we can say for that. So it's MAC spoofing. Like, what is MAC spoofing? So someone might use the term MAC spoofing. So it means like we are overriding the real hardware MAC address with a fake one at the software level. Then what is the broadcast MAC address? So the broadcast MAC address, so like in the previous part, we had gone through the Q&A on IPv4 addressing, where we get to know that in IPv4 addressing, there are two reserved addresses, 0.0.0.0 and 255.255.255.255. And we learned that that 255 one where all the octets have 255. So that basically means it's a broadcast address. As we had seen earlier, that IP allocation happens uh, using the broadcast address. So associated to that broadcast IP address, we have the broadcast MAC address, wherein all the hexadecimal characters are FF, then FF, like that. So all six pairs will be having hexadecimal characters as F. So it means that sends data to all the devices on the local network simultaneously. Then what is the difference between a MAC address and an IP address? So MAC address identifies the device itself and never changes. As we have just seen, that MAC address is associated with network interface card and can never be changed at the hardware level, but it can be changed at the software level. But it differs from the IP address, wherein IP address belongs to a device on a network, and this IP address can be static or dynamic, right? So that's how we can differentiate between a MAC address and an IP address. So overall, we have just covered the short question and answers on MAC addressing in this video. And then if you want to go through the detailed videos which we have covered so far on IPv4 addressing, MAC addressing, and deep dive and things like that, so you can visit the playlist, and we have basically put these links to those videos in the description of this video. So I hope it was useful. Thanks for watching. Happy reading.